Hello everyone. So today we're going to be going sig figs or significant figures. This is a very important concept in chemistry and something you learn in Chem 1 here early on, but it's pretty important, and especially because when you start to get calculations, and especially if your professor is kind of stickler and is like, oh, you're off by one sig fig, and they deduct points from your calculation. And then same thing, you're going to do tons and tons of calculations in chemistry too, if that's something you're going to take. And sig figs are pretty important because, again, you're going to take them into account, and you're maybe not going to get as much lenience as you might with a good professor in chemistry 1, because it's like, well, you should know this, it's expected or whatnot. So very important to kind of get an understanding and, understand how to do it. And so here are actually some of my notes from when I took Chem 1. God, I don't know, many semesters ago. And it just kind of goes over this, right? I think I got this either from the textbook, I can't remember, or my professor's lecture slides, but basically this, right? So any digit that is not 0 is significant. And so we see in the first example, right? 1.234 has 4 sig figs. Captive zeros, right? So zeros that are in between numbers. So for example, 2.06, that counts as a significant figure, right? That 0 is a significant figure. And so this would be 3, right? Leading zeros to the left of the first non-zero digit. So, you're going to see the example, right? 0.08. They are not significant. So this would only be 1 sig fig. And then trailing zeros, right? To the right of a non-zero and to the right of a decimal point, they are significant, right? And so the first one kind of shows something similar to the leading zeros example, right? These are not significant, right? These zeros aren't, but this one is. And the reason why is because this actually does matter, because you were to write it as, 0.042, you go, well, what's the difference between that and the 0.0420? The point is that that 0 is supposed to be more of an exact measurement, especially when you get into, let's say, like in labs. And I can't remember if there's anyone in Chem 1 that, like, you're mixing something and you weigh and it has to be, like, super specific. But I know for sure in, like, Chem 2, you're going to weigh maybe some kind of element that you're going to mix with something or so not, and you will need to record it to, like, that further place of behind the decimal point. And it's not like it's just there for show. It's because it's supposed to be an exact measurement, right? And so that's why that's a sig fig. And then kind of the same thing here, right? So it doesn't really matter the place, right? 21.0 is not the same as just 21, right? This is more supposed to be more of an exact measurement. So that's why those are considered sig figs. And then trailing zeros with no decimal points, those aren't significant, right? And so here, there is no decimal point. Now, with that said, you can get in trouble here, and when we get into some of the practice problems, if you think, let's say you're going to be given a question that's like, hey, write, 3,500 in two significant figures. Like, oh, okay, right? That's not, these are two completely different values, and so you still have to keep its value basically, but change it, and you'll see that's usually in something like scientific notation. But these zeros aren't, and usually that's because I guess they're, not considered as exact in the same way after a decimal point, right? There's like, oh, well, you're just rounding, kind of a thing. And so that's kind of a good rundown. I don't think I'm missing too much. I guess you'll see it kind of in like a little bit more in the practice problems, and we'll get into them. Okay, and so here I have some practice problems for us to do, right? Kind of just going over. These were multiple choice. They were inspired by some study material that I have still from Chem 1. And the first one is kind of what I was just talking about, right? Write this number in scientific notation with the correct sig figs. typically in scientific notation, you might get where you want 4. I've never really seen this. We have the 4 here. That doesn't make much sense. And honestly, I think that's wrong. There's a small possibility that I'm like, no, that's true, but it's like it's not. This is typically the first form, right? It's going to be A. Sorry to give away the answer, but how you kind of do it here is, and I'll write the thing out in case you're like, I don't know about scientific notation, which I feel like it's one of the easier things to get down, but just in case. This -4, right, is because you're going backwards, right? And so you would move the decimal place. You go 1, 2, 3, 4, right? You want it to only should be one digit in front of the decimal point. And then typically, usually there's only about 2. That's how I've seen it most 99% of the time. And so do okay, 8.72 times, and then -4, right? If it was the opposite way, I might not have the room. I'll write it up here. Let's say it was right, 8, 7, 3, 0, 0, 0. Well, the decimal point's here, so we go 1, 2, 3, 4, 5, and so that would be 10 to the power of 5, right? So you would write it like that, right? 8.73 times. I don't have room, but 8.73 times 10 to the 5th power. And that's something to kind of keep in mind, as well as rounding rules still apply, especially if you're given, like, hey, write this in X amount of sig figs. You're going to need to apply it. And what do you know? Sorry. Wouldn't you know? That's our next question, right? Express 96672 in 3 sig figs. I know what I was talking about. People go, oh, okay, well, I'll round here, right? Because rounding rules apply. 9, 6, that becomes a 7. 967, 967, that's my answer. It is not your answer. That is not the answer. Right? Here you need to do it because you still need to keep its value. There are different ways you could do it, usually just rounding. So here, that's not an option. But rounding, however, keeping effectively the same kind of value, right? You would just then do this. That would be kind of the way to do it. That's an option. And if it's not scientific notation is not one of the options. However, right, you would just do this. Round and then move the decimal. 1, 2, 3, 4. Right, and that's this one. It's just the sub. The 4 is not raised as a power, which is right next to it. And then here's another question that you may get, right? Which of the following numbers has the most significant figures? Well, we know this is only 2, right? Because these zeros don't count. So this one only has 2. Okay, we know that this 0 counts. However, this 0 does not. I guess I should have underlined the circle. So that's only 3. Oh, wait, actually, I'm completely wrong. It's 4. Why? Because there's a non-digit 0. I mean, non-zero digit, this 7, to the left of it. So this is actually 4. And then this is supposed to be raised to the 23, formatting things when I copy things over. These are the significant figures, right? So that would be 3. Same thing here. These zeros, they don't count. So only 2 and 1, 2, 0, 1 are significant figures. That would be 3. So our answer would be C, right? Because it doesn't matter. This could be 100. This could be 10 to the power of 100. It doesn't matter. What's showing in the front are scientific notation. Those are significant figures. 3. right? These leading zeros, those they don't count, so just the 2, 0, and 1, that's 3. These trailing zeros, there's no decimal point, so it's just the 4 and the 1, that's 2. So our answer is C, right, which has 4. Now we get into some fun stuff, right? Multiplication and division follow the same rules. You're going to identify the total amount of sig figs for each single thing. And then the easiest way to do it, and I don't believe any professor is that much of a psychopath to be like, yep, you're not allowed to use a calculator on the exam, right? Or on homework or anything like that. I've never heard of it. Maybe, maybe way back when calculators were fresh, but so you don't really need to like show any problems typically. I don't know, if you have a professor that's a real stickler, a real show you every single step of your work kind of a thing, I would just be like, here's what each sig fig I'm saying each like thing has, or sig figs. Here's the value I got. You could just like equal this operation equals so and so from my calculator. That's like what the calculator is giving me, and then here's what I'm giving you as like how many sig figs are going to be in it, or like what the value is when you take in count of sig figs. So how many figures does it have? Well, this question, you honestly don't even need to do calculations. Why is that? Right? Because for multiplication and division, the rule is, it doesn't really matter. This one could have 100 sig figs. Whatever the lowest value number of sig figs are, that's what you're going to use. And so, so for example, another one, right? Let's say it's like 5, 4, 3, 2, 1. That's 1 divided by I was writing multiplication, multiplied by 21. You only have 2 sig figs here. That's what you're going to report your answer in, right? And so in this one, we only have 1, 2, 3, 4. This one has 1, 2, 3, 4, 5, 6. Well, regardless of what our answer is, we're only going to use 4 sig figs, and then we're just going to round. So like, for example, this problem would be, we bust out the old calculator. We go, okay, 4 sig figs, so 1.07, and then the 8 doesn't become a 9. That would be our answer if it was like, what's this calculation? Use correct sig figs. And it wasn't just saying how many sig figs are going to be in the operation. It was, what's the calculation? Use the correct sig figs. That's what it would be. And it's the same thing for multiplying, right? If you swap it and you were multiplying the numbers, you would use the same rules. Now on to addition and subtraction. They follow a little bit different rules, which is just basically you go with the lowest decimal place, right? So you see how far the decimals go out. You go, what's the lowest going to be? Okay, tens, hundreds, right? There's only 2 decimal places in this one, right? There's 3 here, there's 4 here. So you're only going to report your answer with the tenths to the hundredths, right? And so we already know that like this would be wrong, this would be wrong, this would be wrong. It's going to be this one because, there's 2 behind the decimal, 2 behind the decimal. That's our lowest amount. And so it'd kind of be a similar thing where you go, okay, let's do the math on our calculator. And then you report back the answer just using rounding. So that's what it is, right? If I round using sig figs, the 4, it would be a 4 and a 2 afterwards, but we're not reporting those because in our original problem here, addition problem, right, our lowest, we have something that only has 2 spots behind the decimal place, behind the decimal point, and so that's what we're going to report it in. report it in. So these are kind of important concepts to know. I think you don't want to get them mixed up. So obviously, just practicing one equation and one subtraction and knowing that basic rule of like, that's really the things that swap, right? So once you know how to like count what is and isn't a significant figure, when you're doing the addition and subtraction, which you might get a couple questions like this that, especially on your first unit test, the professor just wants to kind of test your knowledge and be like, do you know the rule? But certainly when you're doing calculations, or unit conversions, that's something you're going to probably do early on in Chem 1. Again, you're going to be maybe multiplying or adding or subtracting, right? Anything like that kind of stuff. And a lot of times, I would say like 95+% of professors are going to care about the significant figures. And if they give you a multiple choice question, that even if it's calculation, but it's multiple choice, some professors, most of the time, at least like mine, and granted she was a great professor, you're not going to have one that has the correct sig figs and one that doesn't. Like, even if you necessarily don't report it, right, or you don't know the rule, if you know how to like actually do the calculation, you're going to be like close enough to the answer anyway, so it doesn't matter. But you might get a professor that puts two answers on there. One has a correct sig fig, like how it's supposed to be written, and the other one is like what you would get, like the raw numbers that you would get without taking sig figs into account. And just for the point of trying to trick you. So that's why it's pretty important to know, pretty important to remember. I think the notes are pretty good. Like I said, I think either they were straight from the OpenStax textbooks or my professor's PowerPoint slides. I can't remember, but I hope you learned something. I hope you do well. Yeah, take care.